So I'm audible till last, right? Good. So thank you all for joining today here. I know you have had a long day and I'll try to make this session more interactive and less sleepy. So we'll start with that. Before even starting with my introduction, I would want all you to think of a scenario that you work for a big e-commerce company and you work in the tech department and you have a sales that is about to go live in few hours, let's say 4-5 hours, right? Since you are from the tech department, you want to make sure that everything just works perfectly fine. You have done all your testing, like whatever you could think of that, okay, I'll make sure that these test cases work. You have done all your testing. The sales goes live, you are very excited, but then suddenly you see that the customers are reporting that something is not working. They are unable to check out, like whatever the items they have bought, they are unable to check out. They are facing some issues while checking out. So can you think of scenarios that what might have happened at that point of time where it is all failing, despite of all the tests being done?
Browser compatibility?
Maybe.
Okay.
Possible. Other?
Cloud service down?
Okay.
API down.
That is also possible. Any other reasons?
Device not supported.
That is also possible. But there are multiple customers that are facing similar issues. So,
फिर तो कुछ फट ही गया है.
but sub testing हुआ है already. Like at least the APIs are working fine.
Pure bad luck.
Pure bad luck. Okay. So, huh?
API product वाला नहीं रहेगा.
Like, testing, if you are doing it on production as well, right? Possible, it will be possible, correct. So, sorry?
Denial of service by some state action.
I can't hear properly.
Denial of service.
Achha, denial of service. That is also possible. So, everyone is correct here. So, everyone is correct here. Anything could have happened. What we are going to uncover today is that only that how do we figure out different use cases in our system that can break our system at the end. Even like to see what are the unexpected use cases and how to uncover those unexpected use cases, and we are making sure that our system is resilient enough or strong enough to handle all the expected or unexpected conditions. So my name is Avani. I have been working with BookMyShow from last 3 years now. In total, I have around 7 years of experience into DevOps and SRE. In this whole session, we will be unleashing all these things. So we'll be unleashing chaos, how it came into the picture, the problem statement that we tried to analyze and solve it, what are the solutions that we derived on and that we are using. So whenever we derive any solution, there are some principles that we followed in order to implement that system. So what are the principles for chaos engineering? There are certain scenarios that I have mentioned in the session, and it will be followed by a demo. Now, okay, so everyone makes mistakes, especially we humans are fallible, right? But then it is very important for us to understand that what mistakes we have done and to learn from those mistakes, right? In like Amazon, we all know, is the biggest cloud provider right now, cloud service provider. So couple of years back, Amazon faced a significant outage. Any guesses on the year it happened? Sorry? Okay. Any guesses on the year it happened in?
21 or 20.
No. It was there, but there was one more. So it was in 2011. Maybe you can guess the reason again why it could have happened. Sorry? No. So in 2011, Amazon faced this outage because it was a basically cascading effect of it was triggered by a network configuration change. So we see that from this particular incident, how tightly coupled our applications are becoming nowadays. They are so much interdependent, right? Netflix, which heavily relies on AWS for their streaming services, like recognize that there's a need to improve the system, followed by this incident that happened. So they took some proactive measures in order to understand their system and make their system more resilient or more powerful. So they introduced chaos engineering, and they created a tool called Chaos Monkey. What Chaos Monkey used to do is it used to inject failures into the system at any point of time. So any one day it will just go and it will stop your EC2 instances, or it will add some network latency into your system, so that you know that how your system is actually behaving. And like following this practice, Netflix was able to solve multiple use cases within the system that they were having. They were able to understand the system in a more better way, and they were able to fix all the vulnerabilities that were there in the system. So this is what exactly Netflix did in order to safeguard themselves. They introduced chaos engineering, and the rise of chaos engineering is happening since then. Netflix was the first one to do that and to create this tool called Chaos Monkey. But then since then there are multiple tools in the market for chaos engineering. It's mostly open source. For example, Chaos Mesh is there, which we'll be using in the demo today. Then we have Litmus, we have Germalin. Even the cloud providers such as Azure and AWS are providing chaos engineering tools. So for AWS, we have AWS Fault Injector. For Azure, we have Azure Studio Chaos. Okay, so there are multiple tools in the market which can be explored in order to implement chaos engineering into the system. So BookMyShow, we all know that it's a more of go-to ticketing platform for all your ticketing needs, right? So, but there were some certain problem statements that we were trying to address. I'll just show an architecture diagram so that we all are on the same page, and we are sure that what we are talking about. So you see the application here refers to a web application. So for example, in case you are opening that application into your phone, right? So that is your application. Let's say you want to see a movie, Madgaon Express, consider, and you want to book tickets for that movie. You will click on that particular movie, and you must have seen this page, right, while booking the tickets, right? So consider there are three major APIs that are being called in this particular page. One is the location API, other is the favorite API, and third is the showtime API. Now, the data that is coming on this particular page from these three API indicates that, so for example, you are currently in Andheri, and let's say you want to book the ticket. The first cinemas that will be shown on your page would be the nearest cinemas which are to you, right? So that is being powered by the location API. Then you have favorite API. You see that heart sign along with that cinema, so that is being powered by the failure API. And the third one is the showtime API, the timings that you see, correct? Now consider that for some reason your favorite API is not working. So what should be the impact on your whole system? Should it just crash your system? No, right? Like favorite API I mentioned, consider it as a non-critical API, but over here showtimes API is a very critical API. In case that particular API goes down, should it then impact your system?
Yes.
Right, it should. But then there are multiple ways or solutions around it that we could have implemented in order to understand what would be the blast radius for this. Blast radius over here, I mean, is whenever an error occurs in the system, what impact, like what overall impact it will create on your system, correct? So that is what we were trying to figure out. Whenever an API fails or whenever there are errors in the system, what impact it will create and how we can mitigate those errors. Okay, so we'll just move back to the so what we were trying to understand is how a system will perform. We wanted to do whatever solutions we apply, we are making sure that the performance of that whole system is getting better. We wanted to understand the behavioral study of our system. So for example, in case your APIs are going down or any errors that are occurring in your system, then what would be the behavior of your system? And these errors can be anything, just like as you mentioned in the start, it can be a network error, it can be a database error, any possible thing which is expected, or it can be unexpected as well. So what we were trying to achieve here is overall resiliency of the system should be improved or should be made better. So the solution that helped us was chaos engineering. what exactly we do in chaos engineering is we inject failures into the system and we see how resilient our system is from attacks and different types of failures. We are protecting our system from failures in order to build that confidence that whatever conditions may arise, whatever failures are there in system for XYZ reason, we are able to handle all the unexpected conditions. So, as I just mentioned, we are basically doing a resilience testing of our system. Whatever we do in a very controlled environment. So whatever experiments, whatever cases we are running, we do have a proper and a overall control over that environment. We know where to stop, we know what errors we want to inject, and we know what behavior we want to study for our system. We so whenever we do experiments, we wait for results, right? Over here as well, we wait for results. We analyze those observations that are being made, we analyze those observations, and it's all an iterative process. We keep on doing that till we reach at a point where we know that okay, my system is now enough, like strong enough or immune enough to handle all the use cases that are there that can arrive. So if I'm not sure how many of you are from DevOps or SRE over here.
Please raise your hand.
No.
How many are from DevOps, SRE?
Okay, so in case you might have read SRE book by Google, there is an example in that book that they had a Google processing, basically book scanning processing system, which used to, which used to scan books, and it used to make entries at the back end, right? So there was some configuration or some error into that particular whole process, and it was making multiple entries at the back end, which eventually overwhelmed the system and it resulted in some outage, right? So over here we see that our system was reliable enough, it's Google, it's working as expected, like there was no errors, but as soon as the scale increased because of XYZ reasons, it started breaking. Maybe like that particular whole process could have been avoided in order to, like we could have done multiple test cases before itself whether my system will be able to handle such unexpected conditions or not, right? So that is why we know that chaos engineering for nowadays, for the architecture that we are having right now, it's very important. As I mentioned in the start that there are certain principles whenever we apply any sort of solution, there are certain principles that we need to follow. Likewise in chaos engineering, the first principle says that know the steady state of your system, of your application on which you want to do testing upon. So you know the expected behavior. I just show one architecture diagram here, the same architecture diagram that like the same diagram that we referred before. Over here, consider the showtime API responds back within 2 milliseconds. Okay. Now the showtime API calls another API at the backend for some more details, and the response time still remains within 2 seconds itself, right? Now this is the steady state of my application. This is my application expected behavior is this, that whenever I open this page, I will get my response time in within 2 seconds. Now what my hypothesis will be, let's say in case something breaks over here, how my system will react over here? Will it still get my response time by implementing any solution at the back end? Will I still get my response time within 2 seconds? Either I'll get it or I'll not get it. I might get a timeout, right? So, but how will I arrive to that solution that I need to implement something in between, that even this dependent downstream API fails, my application should still be able to return something, maybe a cache status code or something it should return. It should not just time out, or it should not just log into multiple errors and fail or crash my whole system. So that is what we are trying to achieve here using chaos engineering. So we make hypothesis around it that okay, my expected status, it should return in the response time should be in 2 milliseconds. In case it is not there, what are the other solution that will be deriving around it? So we have made hypothesis. Now we will be performing certain experiments in it. Experiments can be anything. We might inject some network delays in the system. So whatever we are trying to achieve within our system, along with according to that, we will inject certain experiments into the system. I'll come on experiments when we will be doing demo. But consider experiments are different situations or different injections that we do in our system. Uh, then whatever the results are, we adapt them, we apply solutions around it, and we again reiterate the process in order to make sure that our system is now stable enough and it will be able to handle all the conditions. Okay. So I have just listed couple of scenarios over here. There are 100 other scenarios that chaos engineering provides that you can implement in your system in order to make it more better. First is API failure. So in case your API fails, right, your expectation would be that nothing should break in my system. Even if it is breaking, I should get a cached response or something. I should get, my system should not break at any point of time, right? So maybe we can implement circuit breaking in a system. So how do I arrive to the solution that okay, I need to implement circuit breaking in the system? By doing some kinds of experiments, by knowing that my system might fail at this point of time, so I need to implement some solutions around it. Likewise, there can be pod failures, so expectation would be new pod should instantly come up. In case it is not coming, then again we'll need to derive some solutions around it. In case there are network failures, the expectation should be there should not be any drop in between and my system should work very seamlessly. But then we will come to know that okay, in case there is a network error in between my system, then I need to implement certain sort of timeouts in the system. I need to have connection pooling in my system in order to make sure that like whenever there are such kinds of error, your system needs to respond back with certain solutions that you have implemented using these kinds of engineering, and then your system should be able to at least work seamlessly without impacting the customers. So this is the demo application that we will be using today. If anyone has worked with Istio, it's the same demo application that we use over there. It has a front end called the product page. It at the back end it calls two API. One is details, one is reviews. It's basically a bookstore application. What it contains is you will have a name of the book. Along with that, you will have the details of that particular book, and you will have reviews for that particular book. So in case any users want to have buy that particular book, it can that person can refer to the reviews and what are the rating for that particular book, and buy. The website contains this much of data. So I will just show how this application looks something like this. So the Comedy of Errors is the book name. You can see on the left side are the book details, and on the right side are the book reviews. Okay, so now let's go back to the presentation. So these are the three failures or chaoses that we'll be injecting into our system. One is the stress chaos, other is the network chaos, and third one is the pod chaos. In pod chaos, we will be just marking my pod down and see what impact it will have on our application. In network chaos, I will be introducing some package losses and then see how my application should behave. And in the third one, I will be adding some workers to the application that will eat up my memory of that particular product page, and we'll see that how these things are behaving. So let's see some demo now. Is the screen visible?
No. Too small.
No.
Yep. Better. But if you
Is it? Okay. So we will start with pod chaos first. We'll move on to the application. We see that the reviews are being served by from this particular pod, reviews v2. We'll mark this particular pod down right now. So before that, I will be using chaos mesh for doing all these experiments. Major thing to notice over here is experiments, like whatever these experiments you can either create from UI. It's a very UI friendly tool, or else you can apply YAMLs at the backend as well. I will be applying YAMLs because it's more friendly, like for us it's more friendly. So whenever we apply any kind of chaos or YAMLs at the backend, that experiments will be shown over here as well. Okay, so
font is small.
visible, right? So what I have done is I've just taken this particular pod name and I'll apply that. I'll mark this particular pod as down.
So you need to increase the sound now.
I'll increase more.
Yes, please. Check on the video.
No.
More?
It will be visible, but the user will have to.
Okay, more please. One more. Let's make it live.
Enough?
Yeah.
Thank you.
No problem. Okay, so these are my pods that are running at the backend. My reviews application is having two versions, version 1, 2 and 3. Details is having a single version, ratings is having a single version, and likewise my product page. As we introduce that chaos into the system, we can see that my reviews version 2 pod is down right now, right? Now we'll see the impact it will create on the system. Like on the application, you see there's no impact, right? Even if that particular pod was down, the response was served from some other version and it is working as expected, right? So over here the chaos engineering has already been implemented. We know that in case my one version is not working, my response will be served from some other version. Now we'll just okay, even in this UI, if you see the YAML that I've created, it gets applied it over here. It will show all the events that it has been doing. So it first creates that it's a CRD that it's create custom resource definition file. So it creates that CRD and then it applies that particular, like whatever the definition is into that in this particular CRD, it applies it accordingly. So right now it applied on reviews v2 version. And it marked that particular pod down and the response we can see it over here, right? Now moving on, we can stop this. I think we can just pause this experiment from here as well. Moving on to the other one, I'll just move to network. In network class, what I am doing is for the details for this book review application, I'm adding 100% network loss over here. So okay, the action is lost. The experiment is being created. We'll just check over here. It's running. Now we'll see. So you see the details that the reviews that we were getting is just disappeared, right? So now I know in case my reviews is not working, I'll not see anything over here. But if you see this particular reviews are just the data, right? It could have been cached also. But how I know that it could have been cached? Because I know that in case my review application went down, I won't see anything over here, right? So these are these kind of solution that we arrive on while after doing different kinds of experiment in the system, after knowing the behavior of our system. The third one that we will be moving on, we'll just stop this. So it takes couple of minutes to get applied because it basically creates worker into the system. So meanwhile, if you guys have any question, I'm happy to answer.
Okay.
Any questions for Avani?
But 2 milliseconds will be showed, 2 milliseconds expected. That was just for this demo, right?
That is just for this demo. So you see there's one restart in this particular page, right? We'll just check the error for this. So it's out of memory killed, right? So now I know that in case the load increases on my system, it might get out of memory. So maybe I can apply different solutions around it in order to make sure that my system doesn't go into that state and it works seamlessly. So that is why we know that chaos engineering is really needed in order to understand our system, in order to make sure that it does not fail at any point of time, and we are able to build more resilient system and like serve our customer in a more better way. So that's it. Any questions?
Any questions for me?
So these roles come on, well, these responsibilities come under what?
It's majorly a part of SRE and DevOps.
Okay, so both.
But it's more of a collaborative responsibility because in case even for the developers, in case they are developing the application, they should know the behavior of their and because we work in such a environment right now, most of the services are microservices, right? Most of the companies are using those microservices. So it's a collaborative and a distributed responsibility that each person should know that what impact that particular API can make to the system. So for that as well, it's like majorly it's a part of SRE DevOps or the monitoring team in case you're having that separate segregation in your company. But then everyone should get involved in this.
So would you say that it is a architectural decision?
It should be an architectural decision that this should be there in your company. Like you should know that what is failing, where it is failing, and what impact what blast radius it should have on your system.
Okay. Mostly in services, when I have worked with services companies, they don't usually do this kind of impact testing. Yet, yes, there is this testing that what will be a sequential fail if there is a particular API failing in mid. But yeah, this is an interesting take that if there are multiple services being called, what am I saying? If there are multiple servers are being called, then there can be impact impact can be minimalized by creating of some false safe.
Correct. Even using like these tools also provide one interesting thing. There are two more things that you can do. You can create your workflow. So let's say you want to implement multiple failures in your system at one point of time. So you can also keep it scheduled, like at whatever. Let's say you don't want to run it in daytime because in case even if you're doing it on your lower environment, there would be people testing around, right? So you can schedule it for like whatever time you want, and you can have multiple workflows in which you can inject multiple failures. Either you want them to be injected serially or parallelly, like whatever way you want, and then you can decide in the morning that okay, these were the experiments done and these are my results, these are my outputs, and I can act upon them. So that way it can also be done.
One more question. What I have seen that many times the lower environment, that is the code is not consistent on all the environments.
Correct.
So the reliability of a branch, or if I may say a build, is can only be tested on a pre-prod sort of environment only, because many times it works in a lower environment, but at the later stage it will go with something will go wrong and something will have to test in the above environment. So is it based on in everywhere?
This is everywhere.
Okay.
This is like that is why we can use this particular tool as well. So in case you are pushing your code is working till staging, it's working as expected. It might work in pre-prod as well, because in pre-prod you might not see that number of traffic coming, right? The actual traffic, the actual scale comes in production, right? So even in production you can keep these experiments scheduled to a particular level that you know that till this extent my customer won't be impacted and I can perform my experiments.
Can be done in a downtime, then a rolling release is
Can be done in a downtime, can be done later at night when there would be a point of time where your customers are not much there on your websites, right? So you can figure out what time best suits and you can schedule your experiments accordingly.
Okay. Makes sense.
Anything else?
Any more question for Avani?
Yeah, I think one is small question. So, do tools like Chaos Mesh also provide a mechanism to automatically test while chaos is being injected into the system? Because currently, I think for the demo, we saw that you kind of manually checked.
Right now, I don't think Kiosk Mesh has that functionality. Maybe the native tools such as AWS Simulator, that might have it. But then in Kiosk Mesh, we need to actually, like when we were doing that, we actually had to, look for whatever. We had made test cases and we were running those test cases in, let's say we marked one API down, right? So we had some test cases, we were running that test cases in order to understand, okay, what is the impact of this particular API being down. So that thing that you are talking about is more like results analysis, automatically analyzing your results, like whatever.
After you have implemented the solution, let's say again you inject the same failure at that point of time, you shouldn't see those kind of issues that you have faced. So to validate that, I think the automatic validations like white box testing, maybe with hitting the APIs where which is available in the tool, or maybe some other tools that has to be a bit of integration. So
Chaos engineering is relatively a new topic, right? Many companies have not implemented it, though that might come in later releases, but right now I don't think it's there.
Anyone else? Going once, going twice. Sold.
इसको भी पूछना एक जन
Thank you, Avani, for a great talk.
वैसे ठीक है, मैं काटूंगा.
मेरे को